What actually happens inside your body when you stop eating for 23 hours? Most people think they'll get weak, tired, maybe even lose muscle. But something very different starts happening. Around hour 12, your body flips a metabolic switch. By hour 16, your brain begins running on a completely different fuel. And around hour 18, your cells activate a hidden repair system scientists call autophagy. In this video, we're going to walk through the entire 23-hour timeline so you can see exactly what happens inside your body when you eat just one meal a day. Hour 04. The fed state. The clock starts the moment you finish your last meal. Your digestive system is busy breaking down food, proteins, amino acids, carbohydrates, glucose fats, fatty acids. Glucose enters your bloodstream, triggering the pancreas to release insulin. Insulin acts like a gatekeeper. It pushes energy into cells and prevents energy from being released from storage. During this phase, your body burns the glucose circulating in your blood. Any excess glucose is stored as glycogen in the liver and muscles. Think of glycogen as your body's quick-access wallet of energy. Easy to use, but limited. Fat burning doesn't happen here because high insulin keeps fat cells locked. Around 6 to 8 hours after eating, the surge of glucose from your meal fades. Blood sugar stabilizes and insulin begins to drop. At this point, your body switches to stored fuel. This is when many people feel hunger. The hormone ghrelin spikes, sending the familiar message, it's time to eat. But physiologically, this isn't starvation. Your body is simply transitioning from incoming energy to stored energy. Your liver now starts breaking down glycogen to keep blood glucose steady. Energy is still available. It's just coming from internal storage. At about 12 hours, glycogen reserves start running low. Your body now has two choices: slow down metabolism or access deeper energy reserves. Because humans evolved to function during food scarcity, the body chooses the second option. Insulin drops to very low levels, activating an enzyme called hormone-sensitive lipase. This enzyme unlocks fat cells, allowing stored body fat to be broken down into fatty acids. For the first time in the fast, your body begins running primarily on fat. Between 14 and 16 hours, the experience of fasting often changes dramatically. Instead of fluctuating energy from food, your body now uses fat stores, which provide a far more stable fuel supply. The liver converts fatty acids into molecules called ketones. These become a key energy source for the brain. Why does this matter? Ketones are an extremely efficient fuel. Compared with glucose, they tend to produce less metabolic stress during energy production. Many people report a noticeable shift around this time. Clearer thinking, improved focus, stable energy levels. Evolutionarily, this makes sense. Early humans needed heightened alertness during periods without food in order to hunt. Hours 16-18, cellular cleanup begins. Now we reach one of the most discussed effects of fasting, autophagy. Autophagy literally means self-eating. But the term sounds more alarming than it is. It's actually a cellular recycling system. Now we reach one of the most discussed effects of fasting, autophagy. Autophagy literally means self-eating, but the term sounds more alarming than it is. It's actually a cellular recycling system. When new nutrients stop arriving, cells begin clearing out damaged components such as misfolded proteins, dysfunctional mitochondria, cellular debris, some invading microbes. The cell breaks these down and reuses the raw materials to build new proteins and structures. You can think of it like finally sending the cleaning crew into that overloaded warehouse. Broken shelves are dismantled and recycled into stronger ones. This process is associated with improved cellular maintenance and repair. One common fear about fasting is muscle loss. However, during extended fasting, the body releases human growth hormone, HGH, sometimes increasing dramatically compared with baseline levels. HGH helps preserve lean muscle tissue, promote fat utilization for energy. From a survival standpoint, this makes perfect sense. Muscle is essential for movement and hunting, so the body prioritizes burning fat first. At this stage, the body is in a unique metabolic state characterized by low insulin, high fat burning, elevated growth hormone. Approaching the end of the fasting window, several physiological changes have occurred. Insulin sensitivity is very high. The digestive system has had a long rest. Fat metabolism is active, cells have been clearing internal waste. In simple terms, your body is highly receptive to nutrients. This is why the meal that breaks a long fast matters. How to break an OMAD fast properly. Because the body is highly absorbent at this stage, the quality of food is crucial. A balanced approach might include 1. Protein, repair and rebuilding. Examples: eggs, fish, chicken, lean meat. Protein supplies amino acids needed to rebuild tissues and enzymes. 1. Healthy fats, sustained energy. Examples: olive oil, avocados, nuts and seeds. These help maintain steady energy and avoid sharp insulin spikes. 1. Vegetables and micronutrients. Examples: leafy greens, cruciferous vegetables, fermented foods. These provide essential minerals like potassium and magnesium, which help prevent fatigue or muscle cramps. The adaptation period. Switching directly from constant eating to OMAD can feel difficult at first. The body needs time to develop metabolic flexibility, the ability to switch smoothly between glucose and fat for energy. During the first week, some people may experience headaches, fatigue, irritability. Often this happens because fasting lowers insulin, which causes the kidneys to excrete water and sodium. Replenishing electrolytes, especially salt, can help. A gradual transition works best. Delay breakfast by a few hours. Skip breakfast entirely. Gradually shorten the eating window. OMAD and extended fasting are not appropriate for everyone. People who should avoid or consult a healthcare professional first include pregnant or breastfeeding individuals, people with eating disorder history, those taking medication for diabetes or blood pressure, individuals with significant metabolic or hormonal disorders. Fasting is a metabolic stressor, and it should be approached carefully. A different relationship with hunger. In today's food environment, hunger is often treated as an emergency. But biologically, hunger is simply a signal, not a crisis. For many people, compressing meals into a single window changes their relationship with food. Instead of constant fueling, the rhythm becomes closer to an ancestral pattern. Search, eat, rest. The body shifts from relying on continuous incoming calories to using its own stored energy efficiently. And when that switch flips, the metabolic warehouse finally has time to clean itself. Thanks for watching. Please don't forget to like and subscribe.